Hello, today we're looking at topic 3.3, sine and cosine function values. So we're going to dig into sine and cosine a little bit more than we have so far. It does tie back to things that we have been talking about in previous lessons. So let's do a little recap and then extend it into this lesson. So coordinates of points on a circle centered at the origin. So remember we said that if it was angle theta, was in standard position, then it's centered at the origin and it has a radius of r. Then there is some point on the circle that is created when the terminal ray intersects the circle. So point P is where the terminal ray intersects the circle. So it's talking about this little piece right there. And in lesson 3.2, we learned that we could call that cosine theta, which is x over r. So if you imagine horizontal displacement, vertical displacement, then this was my x, my horizontal displacement, and this was my y, my vertical displacement. And that if we were trying to find our cosine value up here in this coordinate, we could do cosine theta is x over radius, and sine theta is y, or the horizontal displacement over the radius. But if we wanted to go ahead and isolate these equations and set x equal to each other, I can multiply both sides by r, and then I can end up with x equals r cosine theta. And I can multiply both sides by r here, and I can end up with y equals r sine theta. So I can actually turn this ratio into an equation for x and an equation for y just by doing the basic math that we've been doing since Algebra 1, and that's multiplying both sides by denominator to get rid of the denominator and make them not be fractions. So we talked about how this coordinate when we first started was x and y, and then we talked about how it was going to be cosine and sine. Now we've added one more layer to that, and now it's r cosine theta and r sine theta. All right, so all of those are things that we've drawn or drawing upon from different lessons that we've done so far. And so we're going to keep track of that as we go through some of these examples. All right, so example number 1, the figure at the left shows a circle of radius 4. So that means from the center to the point on the circle is r equals 4. And it's an equilateral triangle. So we've created this equilateral triangle right here. What are the coordinates of point P and of point Q? So let's kind of just step back for just a minute and kind of fall back on some of the things that we've been learning. So we know if we have this equilateral triangle here, then we have an equilateral triangle right here, right here, right here, and we're going to have 3 down here as well. So we talked a little bit about, if you remember, we talked about Trivial Pursuit and that little pie piece and how we could put the pies in there and it makes this nice circle. So we have those pieces of pie here. They're just not as pretty with, you don't have all the colors and stuff that represent the categories, but it's the same idea. So what we in essence have here are 6 inscribed equilateral triangles in the circle. Okay, so now thinking back to what we've been doing, if we have this triangle that's in this part of our circle, then how much is this in relation to all of the other pieces of this circle? So how many pieces would there be? There'd be 1 here, 2, 3, 4, 5, and 6 if we reflected these lines down here. So 1, 2, 3, 4, 5, 6. And so what we're looking at then is one piece or wedge of this circle, and that is 1/6 of the circle. And we learned that if we were going to take 1/6 of 2 pi, because that would be the whole distance around the circle, then that simplifies to pi over 3. So then what that tells me is the measure of this angle from the positive x-axis up to P is pi over 3, because that is an angle in standard form. Okay, so then if we were going to come up with the coordinates for Q, if we know this is pi over 3, then we can do our count around, if you will, and this will be 1 pi over 3, and so we would come over here to Q, which could be 2 pi over 3. So as we keep enforcing our radian measures around the circle, I'm just counting around to get to that. We know that this has a radius of 4, and that my theta angle from here to here is going to be represented by this piece. And then if I take that angle to the second terminal side, which would be from here around to here, then that's going to be a different angle. It still does have this radius of 4 over here, so we can definitely carry that piece of the problem over. So according to our new form of the coordinates on the circle, we're going to be using this. So we're going to be saying r cosine theta, comma, r sine theta, and making sure we get those in the right order. Remember, we're going to enter those alphabetically, C before S, just like if you're graphing the coordinate xy, we graph x before y. Okay, so if we do point P, that's the first one. So we're talking about this distance from the positive x-axis to the terminal side of the ray, which is at point P. Then we can say the radius of the circle is 4. And then we can say cosine, and what's the angle itself? The radian measure of the angle is right up here. We just calculated that pi over 3. Then we can say 4 sine theta, and the angle we just calculated once again is pi over 3. Those obviously in a coordinate point representing that point on P, those are going to both be the same angle that we're finding with cosine and sine. All right, then the second point was point Q. And so as we are looking at this, we're talking about the positive x-axis here opening all the way to the terminal side. And where is the terminal side at? What radian measure? 2 pi over 3. What's the radius here of this angle? Still r, because we learned in geometry that there are an infinite number of radii in a circle and they all have exactly the same measure. So then again, we would say the radius is 4 and we would say cosine, but this time we're not talking about pi over 3, we're talking about 2 pi over 3. And then 4 sine 2 pi over 3. And so we have found what would be the coordinates of that point. And what we're going to do now is we're going to be taking and putting some actual values to those radian measures and being able to do a little bit more with them than we have so far. Okay, so in example 2, we are going to consider the points P, Q, R, and S, which are labeled above in the circle, and we're going to find the values of the following angles down here. So let's go ahead and count off and mark our quadrantal angles. So we know we can start at 0, and this would be half of the distance around, or pi over 2. And then the half distance around the circle from 2 pi, half of 2 pi is just pi. Then we're 3/4 around the circle, so this is 3 pi over 2. And then we're right back to where we started, so this could also be 2 pi. So these are all angles that we calculated earlier in earlier lessons. So let's kind of recap now that we know a little bit more about what's going on. So first off, what's the radius of the circle? It's 1, okay? So if the radius is 1, then when we're finding the cosine and sine values, then this first one is your cosine and the second one is your sine, just like we talked about in the previous example. So go ahead and pause your video right now, and using your quadrantal angles here, I want you to calculate all of these sine and cosine values for these quadrantal angles. So pause your video. All right, let's see how you did. So remember that the first part of the coordinate represents the cosine value. The second part represents the sine value. And we said now at the beginning of this lesson that we were going to think of that point in terms of radius cosine and radius sine. Well, what is the radius in the circle? It's just 1. So 1 times anything is going to produce what it is you're multiplying by. So you should have found that cosine of 0 was 1, sine of 0 was 0. And so if I go over here to the 0 angle, then cosine is the first one, so that's 1, and sine is the second coordinate, which is 0. Keeping that pattern in mind then, as cosine at pi, it's -1. At sine of pi, it's 0. At cosine, now we're up here at pi over 2, so cosine is 0 and sine is 1. So cosine in this case stays put right here, 0, and then you would increase your unit up out to the circle at 1. And then cosine of 3 pi over 2 is 0, and sine of 3 pi over 2 is -1. So hopefully you were able to get all those. The quadrantal angles are the nice, easy ones to work with, so they're pretty friendly. All right, so in example 3, we're going to draw an inscribed isosceles right triangle in quadrant 1. So here is my triangle. So go ahead and draw that on your paper. And we are on a unit circle. So what do we know about isosceles triangles? Isosceles means that we have two sides the same. Not the hypotenuse, but the two sides. So my hypotenuse is right here, which is also going to be the radius of my circle. And then from here to here would be one leg, and from here to here would be the other. So the horizontal displacement and the vertical displacement are the two sides of the isosceles right triangle. The right triangle is right here on the x-axis, just so you know. We don't ever usually put those right triangles on the vertical axis or at the origin. All right. So what I would like for you to do is go ahead and determine the coordinates of pi over 4. So let's start out first by figuring out what pi over 4 is. If you remember, we did create pi over 4s last time, and we said to get this point right here that's technically pi over 4, then in order to calculate that, we would take half of pi over 2. So if we take half of pi over 2, we get pi over 4. And so that pi over 4 angle splits this quadrant into two angles, the one right here and the one right here. So if I reflect this point over into this quadrant, it's going to be halfway between, and halfway between. So I'm going to have this situation here, here, and whoops, I didn't put my point here. And I'm going to go down here. So if I look at that circle, then from 0 to pi over 4 is how much of the circle? Well, it's 1/8 of 2 pi. And when we simplify that, as we have been doing, that's going to get you another way to look at your pi over 4. So there's different ways you can look at figuring out what that angle measure is in radians, but hopefully by now we know that when it's halfway, it's pi over 4. And then as we have practiced numerous times, we can count our way around. So I'm going to take this pi over 4 and I'm going to move it in here so it's inside, because we're actually going to work on coordinate points for pi over 4. So this would be 1 pi over 4, 2 pi over 4, and you're counting your way around the circle. So go ahead and fill in those pi over 4 angle measures. Okay, so let's talk about what we know about right triangles. We know that we can use Pythagorean theorem, and we're going to use that now to determine the coordinates that would go on this point. So right here, nice easy coordinates, 1, 0, 0, 1, -1, 0, 0, -1. But these aren't on the quadrantal markers. They're within the quadrant, specifically halfway between the two quadrant markers. So what we know about Pythagorean theorem, we're actually going to be using this as our hypotenuse, which is our R value. So we're going to have r squared equals x squared plus y squared. So what do we know about this triangle right here? We know that an isosceles right triangle has two equal legs. So that means this side and this side are the same measure. And so what that tells me then is my x value has to equal my y value. So how is that going to be helpful as I am finding the length? It is going to be helpful because that tells me if x equals y, then this can be written as r squared equals x squared plus y plus, oh, excuse me, x squared. That was the whole point of that. So those are the same. That's what this piece is telling me. So now we can pull out one more piece of information because this is a unit circle. And what do we know about unit circles? That the radius is 1, just like we know Pythagorean theorem is x squared plus y squared equals, in our case, r squared, but you could say x squared plus a squared plus b squared equals c squared. All right, so that means I can come in here and replace my r with a 1 because 1 squared is 1. And that's going to equal 1x squared plus another x squared, or 2x squared. And the x squared by itself, we're going to divide both sides by 2. So now we have x squared equals 1/2. And when we take the square root of both sides, we're introducing that symbol into the problem. So that's going to be plus or minus 1, because the square root of 1 is 1. Or if you need to think about it like this for right now to kind of get your mind wrapped around that when you take the square root of a fraction, you're actually taking the square root of the top and the bottom. So technically, I'm going to flip this around just because I like to have that x first. And I'm going to say plus or minus 1 over square root of 2. So that's how we get to that point. All of our unit circle values will be rationalized. So we're not going to label the triangle with 1 over square root of 2. We're going to go ahead and rationalize that. And in case you forgot, rationalizing it means multiplying the bottom by some radical that's going to make the radical on the 2 go away. And that's going to be square root of 2. So then I have on top what I do to the bottom of a fraction. Obviously, I have to do to the top. So that equals plus or minus 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is square root of 4, which is simply 2. So what that tells me then is the vertical displacement is going to be square root of 2 over 2, and the horizontal displacement is also going to be square root of 2 over 2. And plus or minus, you can just kind of think about some of these are actually going to go in the negative direction. Some of them are going to positive direction. So it's at this point in this quadrant, because our horizontal displacement is positive and our vertical displacement is positive, then this coordinate right here is going to be square root of 2 over 2, square root of 2 over 2. And so we have our coordinate now for pi over 4. And so what I want you to do now is to reflect this point over into the pi over 4 angles in each of the other quadrants, quadrant 2, 3, and 4. So pause your video and add your points. So how did we do? Did we get all of our coordinates? So once you figure this out in the first quadrant and you get this, everything in the first quadrant is positive. We talked about that because the horizontal displacement is positive and the vertical displacement is positive. So then it becomes very easy, especially on pi over 4s, because since the first and second quadrant coordinate of the point are the exact same number, then we just have to worry about negative, then positive, negative, negative, positive, then negative down to get to those points. So now we know 4 more angles on our unit circle. We've looked at quadrantal angles. We're getting ready to look more at 6, but we have the 4s down as well. Okay, so for example 4, we just looked at multiples of pi over 4 above. So now we're going to kind of look at multiples of pi over 6 in our circle here. And so we're going to do that by looking at one of those equilateral inscribed triangles like we did in example 1, where we had all of our 6 inscribed triangles. So here I'm going to look at the one that goes from this quadrant to down in this quadrant. And so what do we know about equilateral triangles? We know that all sides are the same. So if all sides are the same, then this distance of 1 means we have half of the one above and half of the one below. So if I'm looking at this triangle inscribed again in the first quadrant only, then I'm talking about this triangle here. And it has a length of vertical displacement of 1/2, and a ray, or the radius, is 1. So I want you to use your Pythagorean theorem again to find the distance of this side right here. That's what we're looking for. So we know right now, by knowing the vertical distance, that this is going to be 1/2 in my coordinate. But now I need to know what is the horizontal displacement. And again, we're going to use the Pythagorean theorem to find that. So pause your video, do the Pythagorean theorem, and find the length of the horizontal displacement. All right, so how did you do? So we squared this and got a 1/4. We moved the 1/4 over here. So 1, turn that into 4. So 4/4 minus 1/4 gives us 3/4. When I take the square root at the top of my fraction, I get root 3. When I take the square root at the bottom of my fraction, I get 2, plus or minus. So since we are going in this direction, a positive displacement, that's going to be positive root 3 over 2. So now that we know the horizontal displacement and the vertical displacement, we can actually calculate our point here. So let's say we wanted to reflect point P over here into quadrant 2. And what would that coordinate point look like? Well, same as before, we're moving in a horizontal displacement of negative to a positive vertical displacement. So this would be negative 3 over 2, comma 1/2. And my second question then is, what would that angle be? Well, we've talked about how we can count radians, and we're getting to where we're kind of learning to think in terms of radians. But if this is pi over 6, then if this is reflected over here, this has to be a multiple of pi over 6 as well. So remember we talked about we could count it around. Pi over 6 is just this angle here. There are 3 of those triangles here. However you want to think about that. But go ahead and pause your video for just a second. See if you can figure out how you would count this point around here, P, to, let's just call this point C, just so we have a name to talk about. So what would you say that would be? Just see if you can extend the concepts we've been working on. What multiple of 6, of pi over 6, would this coordinate point on our unit circle be? Pause your video. How'd you do? Did you get 5 pi over 6? Well, I hope so. But again, if we were going to count it around, we could say 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So just keep that counting skill around. But as we come back to the point we were talking about, point P, we could actually come up with a coordinate now that we know, because remember now we're using r cosine of an angle, r sine of the same angle. So I could say r, which is 1 cosine of pi over 6, because remember we're looking at point P. And then I could say r, which is 1 times sine of pi over 6. And now I could actually come up with some of those values because cosine, so remember we're looking here, and this is cosine of sine. So cosine of the angle pi over 6, which is what P is. So cosine of pi over 6 is root 3 over 2. Root 3 over 2 times 1 makes this coordinate root 3 over 2. So it's kind of tying back to what we did here with our displacement. So in this case, then I would say sine of pi over 6, which is going to be the second coordinate we found a moment ago, which is 1/2. So then I would say 1 times 1/2, and that's just going to give me 1/2. And that reemphasizes what we've been talking about with those coordinate points, the displacement and the actual connection to a cosine sine angle value on the unit circle. One important note, notice that we found 2 values of x where the Pythagorean theorem produced our displacement that we were looking for. And we found out that when that happened, it was in a different quadrant. So we were talking about angles in different quadrants on the unit circle. And so with a y coordinate of 1/2, use the symmetry at this point, what would be the radian? Okay, and so that's the angle. So again, trying to see here if you understand what these numbers represents displacement, which represents the actual angle. And in this case, it is asking for the radians, the measure in radians, which we found right here is 5 pi over 6. So that's actually what we are doing here. So our conversation kind of comes full circle back to the angle we started with. So we found the displacement using Pythagorean theorem. We were able to use the horizontal and vertical displacements to come up with a coordinate. We were able to look at what this point would look like in the second quadrant by knowing how we can use our transformations to get this point and how we can adjust the coordinates of this point from root 3 over 2 1/2 to negative root 3 over 2 1/2. And then we looked at how we know we can count around our radian measures because of where those places are located. And so we counted by pi over 6s. And so there's 2 here. So that's 1 pi over 6, 2 pi over 6, 2 pi over 6, 3 pi over 6, 4 and 5. So I think I got off on my counting there. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Here we go, 5 pi over 6. All right, so tying all of that together and making sure through this note down here that we understood what that point, that multiple of pi over 6 would look like in the second quadrant, because we would be talking about going from here around to this angle. So we're talking about this angle right here. All right, so we have talked about a lot of things here. So we're going to move on to looking at all of these points that we've been talking about. So next page, you're going to see a new unit circle. And the unit circle below has all of the points that we've been talking about. So we've been talking about pi over 6. We know if we count around the circle in terms of pi over 6, all of our pi over 6 angles are going to simplify to a pi over 3 when we hit those that they have in common. So remember that pi over 6 and pi over 3 are complementary angles in a triangle, which means they're all using the same side. So pi over 6 would have a horizontal displacement of root 3 over 2 and then a vertical displacement of 1/2. If we go up here to pi over 3 at this point in my first quadrant, it's only going to have a horizontal displacement of 1/2 and then have a vertical displacement of root 3 over 2. All right, so what I would like for you to do now is we're going to use the properties of symmetry to reflect these points. So I'm talking about the points that are here on the quadrant 1 part, from quadrantal angle to quadrantal angle, and the 3 angles we've been talking about here in the middle. We just talked about how we did create this angle coordinate a moment ago, and now we know that because they're complementary, the horizontal displacement becomes the vertical displacement at pi over 3, and the vertical displacement of pi over 6 becomes the horizontal displacement of pi over 3. All right, so what I want you to do now is pause your video and move and transform these points into all the quadrants and come up with the radian measure. So we're going to count all of these lines by radian measures, and then we're going to have a coordinate point on all of these. So think about this as having 3 dots. Here, you're going to write the radian measure inside. You're going to write the coordinate on the outside. And then in quadrant 3, you're going to be looking at these 3 angles, writing their radian measure on the inside and their coordinate on the outside. And then in quadrant 4, you're going to look at these 3 angles, write their radian measure on the inside and the coordinate on the outside. So pause your video and complete your unit circle. All right, let's double check and see how we did. So we have 2 pi over 3, 3 pi over 4, 5 pi over 6, 7 pi over 6, 5 pi over 4, 4 pi over 3, 5 pi over 3, 7 pi over 4, 11 pi over 6. So how did we do on the radians? Are we thumbs up on the radians, I hope? All right, then I went through and did my pi over 4s next. So I knew negative horizontal displacement, vertical displacement is positive. Here, both are negative displacements. Here, the vertical displacement is negative. So I just set those in, and then I started with my pi over 6, and I worked my way around. I did color code them just so as you're looking right now, it might make them a little easier to see, but this one is a reflection over here. So that means the horizontal displacement is negative, so it's negative root 3 over 2, 1/2. When we're down here, 7 pi over 6, so that means they're both negative, so negative root 3 over 2 and negative 1/2. And then when we're in the fourth quadrant over here at 11 pi over 6, that's root 3 over 2, and then a negative, can't see my negative there, it looks like it's on the line, negative 1/2. So that's going to be that negative vertical displacement. If you count from 1 pi over 6 to 2 pi over 6, simplifies to pi over 3, which means now the displacements have changed. So what was the horizontal displacement in pi over 6 becomes the vertical displacement in pi over 3. What was the vertical displacement in pi over 6 becomes the horizontal displacement in pi over 3. And so then I reflected that into the second quadrant. So it was a negative horizontal displacement, positive vertical displacement. So negative 1/2 root 3 over 2. Then when I reflect it down into quadrant 3, both displacements are negative. So negative 1/2 and negative root 3 over 2. When I reflect it over here into the fourth quadrant, the vertical displacement is negative. So that's 1/2 negative root 3 over 2. And so that got us all our pi over 6 and our pi over 3 answers. So go ahead and pause your video, and I want you to answer all of these questions based on your unit circle values above. And remember, it's 2 pi over 3 is the angle that has a sine value of what? And the what is what we've been looking at and working on building in those coordinate points. So remember that your coordinate points are cosine and sine. You don't have to worry about the r right now because the r in a unit circle is all 1, which means any of the values that you're calculating would just be multiplied by 1. Okay, go ahead and pause your video one last time and answer questions A through I or L. Pause your video. Okay, so let's see how you did. Sine of 2 pi over 3 equals root 3 over 2. Cosine of 5 pi over 4 is negative root 2 over 2. Cosine of 11 pi over 6 is root 3 over 2. Sine of 7 pi over 4 is negative root 2 over 2. Cosine of 4 pi over 3 is negative 1 half. Sine of 7 pi over 6 is negative 1 half. Cosine of pi is negative 1. Sine of 3 pi over 2 is negative 1. Cosine of 2 pi over 3 is negative 1 half. Cosine of 5 pi over 3 is 1 half. Sine is 0, and cosine of pi over 2 is 0. So again, using these unit circle values to be able to identify trig ratios from that information. And if you noticed, when we talked about this, we calculated prior in the lesson and other lessons some of these values. Today, we kind of found out where all the coordinate points are coming from inside the quadrantal markers, which are here like at 0, at pi over 2, at pi, and at 3 pi over 2. And so once we had established that we could develop these ratios, then we didn't have to recalculate them in every quadrant, did we? We only had to know how the displacement was going to change and whether the positive was going to be a negative or negative was going to be a positive when we reflected that particular point into a new quadrant. So it's very important to think about some of the things we talked about in that in this quadrant, when we graph any point, it's positive, positive. In this quadrant, when we graph any point, it's negative, positive. In down here in the fourth quadrant, it's going to be negative, negative. And over here in the fourth quadrant, it's going to be positive, negative. We reviewed and made sure we remembered how to label the quadrants, make sure the order. Sometimes students get them numbering backwards, but that's quadrant 1, quadrant 2, quadrant down to this one, 3, and quadrant 4. And it's not wrong to label them with numbers, but typically speaking, we use Roman numerals or we say Q1, Q2, Q3, Q4, just to keep them from getting confused with other numbers that we've been talking about. So pulling all of this together in one spot. So as you can see, I didn't say you have to memorize all these coordinates because you have the coordinate here. It's just making sure you can apply that ratio. All right, so go ahead and make sure you practice your daily practice to make sure that you can not only label a unit circle and be able to come up with all of the coordinates and radian angle measures, but also that you know how to use that unit circle to be able to find all of the ratios based on sine and cosine. Thanks so much, guys. I'll see you next time.